Hi, welcome to the video on the gas law practice. So we are going to go over the part 2 problems. The part 1 problems you can get from your gas law notes, your 5.3 notes, with the exception of question 8, where you're converting from degrees Celsius to Kelvin. That you can look up using Google, or you can use your 5.1 notes for that. And for the part where it says converting from atmospheres to kilopascals, again, for this one you would Google that. That is not currently in your notes. So all of this information at the top, part 1, you get from your notes. So let's quickly go over the 5.3 notes, which you should have copied. The top half of the notes goes over what an ideal gas is and the kinetic molecular theory. We're not going to go over that. That's just kind of some key background information. But based on this information, these gas laws were devised. And if you look here, there are 6 gas laws. And the gas laws essentially show you the relationships between different properties of gases. So, for example, in the first one, Boyle's law, it shows the relationship between the pressure and volume of an ideal gas. And that relationship is represented as an equation. All of these relationships are represented as equations. So you can use that to not only qualify the changes, but you can also use that to quantify them, quantify properties. All right, so if you take a look at the gas laws, just take a moment to look at the gas law equations. You'll notice that the first 5 involve a side with 1 and a side with 2. And so these first 5 are used to predict changes to one property when 1 or 2, in the case of the combined gas law, have changed. Okay, so in fact, in the combined gas law, you can use it to predict changes for multiple properties. But so you change one property, how does the other property change? If you change the pressure in this case, how does the volume change? And so if we look at the Boyle's law, which is P1V1 equals P2V times V2, that means pressure 1 times volume 1 equals pressure 2 times volume 2. You could use this equation if you were given, let's say you were given, the pressure of a gas is at 5 atmospheres, and it's 3 liters of the gas. What's going to happen to the volume if I double the pressure to 10 atmospheres? Okay, so in that case, your P1 would be 5 atmospheres, your V1 would be 3 liters, your P2 would be 10 atmospheres, and you have to figure out V2. So that's one way of using this equation. You can also look at it and see that for this equation, if you increase the pressure, so if you double the pressure, so if you're going from P1 to P2, you've doubled that, you have to decrease the volume by the same factor. So the volume has to be half. And it means it's an inversely proportional relationship. So the P1V1 equals P2V2 is an inversely proportional relationship, and that's important. You can predict properties of gases in this way. For the Charles law, you have V1 over T1 equals V2 over T2, so this shows the relationship between volume and temperature. This is directly proportional. As in the Gay-Lussac's law, P1 over T1 equals P2 over T2. So you see the ones with the fractions, they're directly proportional. And Avogadro's law as well, V1 over N1 equals V2 over N2. This is the relationship between volume, and N stands for moles. Okay. The combined gas law, again, this is used when multiple things are changing. So you can read the example problem here, but it sort of does the same thing. You can use it to predict changes. The last one, the ideal gas law, is used generally when you're given the properties of a gas and you want to know an unknown property. Let's say you're given the pressure, the moles, the temperature, you want to figure out the volume under those conditions, you would utilize the the ideal gas law. Just plug your values in. Now I just want to quickly remind you, N stands for mole here. So the N is moles. R is a constant. And when the pressure is in atmosphere, volume is in liters, and temperature is in Kelvin, that constant is 0.0821 liters atmosphere per K mole, per Kelvin mole, okay? All right, that's enough of that. So these are all the notes. Let's take a look at these problems now. So in this first problem, it says a tank contains 0.25 moles of a gas at STP. What is the volume? So let's look at the key information that they're giving us. They're giving us the moles, so we know what moles are. And the symbol for moles, remember, is N in these gas laws. When you see STP, that's actually key information as well, because they're telling you it's at standard temperature and pressure. So they're actually telling you that the temperature, standard temperature, is 273 Kelvin, and the pressure is 1 atmosphere. And you're solving for the volume. Now, take a look and see if you can figure out which of these equations you can use for that. Well, first of all, is there anything changing here? Do you have any changes to the pressure, volume, temperature? No, they just want to know what is the volume under these conditions. So in that case, since there are no changes, we're not going to use any of the first 5. We're going to use this one, PV equals nRT. So what you're going to do is you're going to plug all this information into the PV equals nRT equation. Remember that R is 0.821 liters atmospheres per K mole. Okay? So go ahead and plug it in and solve. There is another way of solving this besides using the ideal gas law. The other way of solving it, if you like dimensional analysis, because one thing that's super important to know is that at STP, one mole of a gas has a volume of 22.4 liters of an ideal gas. What you can do is you can use this as a conversion factor. So because the gas is at STP, and you're given the moles and you want to know the volume, you can use this as a conversion factor. So the way that would look like is you take your given 0.25 moles over 1 just to make it a fraction. And the second fraction, you're going to take these two pieces of information to set it up such that at the end, you're going to have your volume in liters. So that's what you're aiming for. So you want to set it up so that the units you don't want cancel out, the units you do want you can keep. So that's how you would solve this problem. I'm not going to go over into the answer because you do have the answer key, but I'm just helping you with the clues. All right, next one. A high altitude balloon contains 30 liters of helium gas at 130 kilopascals. What is the volume when the balloon rises in altitude where the pressure is 25 kilopascals? Okay, so a couple of things. You need to know what the units are telling you. 30 liters. Liters is a unit for volume, so that's a volume. And notice that the volume is changing. They want to know that the volume is changing. So this is our initial volume, so I'm going to name that a V1. Pascals is for pressure, so that's your P1. So initially, this is initial pressure, initial volume. Now the pressure changes to 25 kilopascals, that's your P2. And they want to know V2. And they're telling you the temperature remains constant. So that's an important clue. All right, so with this information, knowing that you're given P1, V1, P2, and you're trying to solve V2, which equation are you going to use? Of course, you're going to use that first one, P1, V1 equals P2, V2. Again, I'm not going to go into how to solve it, but this is the equation that you're using for this one. Now, one thing I want to note here is that the pressure is in kilopascals, and that's okay. When you're using these equations, your pressure can be in kilopascals, it can be in torr, or or millimeters of mercury, and that's because they scale to atmosphere, so you don't have to change those units unless you're asked to change in the problem. If they say reported in atmospheres or something, you don't have to change those units. The only unit you always have to change and make sure it's in Kelvin is temperature. Okay, so temperature must be in Kelvin. But for these problems where you're looking at changes for the first 5 gas laws, you don't have to change the pressure units or even the volume units, as long as they scale to, for pressure scales to atmospheres and liters, and for volume scales to liters. Of course, you have to make sure they're consistent. So, for example, if your P1 is given in kilopascals and your P2 is given in atmospheres, you'll have to convert one to the other. All right, next one. The volume of a gas-filled balloon is 30 liters, so that's your V, at 40 degrees Celsius. So they're giving you the temperature, okay, we're going to have to look at that, and 1.53 atmospheres, so that's pressure. This is T. What will the volume have at a standard temperature and pressure? So again, they're giving you some more information at SCP. So remember, SCP, whenever you see that, they're giving you 2 things. They're giving you temperature, it's 273, and pressure is 1 atmosphere. So we have to figure out what situation are we using here. Is there a change? Yes, there is, because if you look at the temperature initially was 40 degrees. It went from 40 degrees Celsius, which we'll have to convert to Kelvin. Let's go ahead and do that now. So 40 plus 273, which I think is 313 Kelvin. Okay, so the temperature initially at 313 Kelvin, so that's our T1, went to 273 degrees Kelvin. That's our T2. And the pressure was initially 1.53 atmospheres, so that's our P1, and it went to 1 atmosphere, that's P2. So, and we have our volume here, our V1. They want to know what V2 is, because there's been a change here. So look at all the things that are changing. We have a P1, a V1, a T1, and V2, T2, P2. All of these things are changing. Pressure, volume, temperature. Which law are you using? Well, which is the one that has that? Combined gas law. P1, V1 over T1 equals P2, V2 over T2. All right, so this is the one you're going to use to solve. All right, let's look at question number 4. A balloon inflated at room temperature at 24 degrees Celsius, so that's our temperature. We'll have to change that to Kelvin, of course. Has a volume of 4 liters, that's V. The balloon is then heated to a temperature of 58 degrees Celsius. That's also a T, a temperature. What is the new volume? So we're looking for V2. They're giving us T2. It's in 58 degrees Celsius, so we're going to have to convert that to Kelvin by adding 273. You can figure that out. Okay. They give us T1, 24 degrees. So again, you have to convert that to Kelvin. And then they also give us V1. So it's initially at 24 degrees Celsius, initially has a volume of 4 liters. They want to know what's the volume when the temperature increases to 58 degrees Celsius. So given this, you have V1, T1, V2, T2. Which equation are you going to use? You got it. It's that Charles law. All right. Last 2 problems. The pressure in an automobile tire is 198 kilopascals at 27 degrees Celsius. At the end of the trip on a hot sunny day, the pressure has risen. So there's been a change there. Okay. What is the temperature of air in the tire? All right. So they're giving us, clearly there's a change. We have a P1. We have a T1. Don't forget to change that to Kelvin by adding 273. And the pressure changes to 225 kilopascals. So you have a P1, T1, you have a P2, you're looking for a T2. Which equation are you going to use? Yep, Guy-Lussac's equation. Now, just note, when you solve this problem, think about what your temperature is going to be in. It's going to be in Kelvin, so you're probably going to get a large number, and that's okay. They're not asking us to convert it to degrees Celsius, so you can keep it in Kelvin. But if they do actually convert it to degrees Celsius, make sure that you do that conversion at the end by subtracting 273. Last one. What is the pressure? What pressure will be exerted on a 0.45 moles of gas by 0.45 moles of gas at 25 degrees Celsius if it contained in a 0.650 liter vessel, and they're giving you R. All right, so has there been a change here? No, they're just asking what is the pressure under these conditions. All right, so they're giving you the moles, and remember moles, the symbol for moles is N in these gas laws. They're giving you the temperature in degrees Celsius, so you know what you need to do with that, right? Convert it to Kelvin by adding 273. And they're giving you the volume. And if you're not sure what these things are, you have to know the units. So when I see liters, I know that's volume. When I see degrees Celsius, for example, I know that's temperature. So knowing the units is important. All right. So given that we have this information here and there's been no changes, what equation are we going to use? Well, there's only one that involved no changes, and that's the ideal gas law. All right, so we just want to calculate the pressure under those conditions. So you're going to use PV equals nRT. Don't forget the R is this value here, 0.0821. All right, I hope you found this video helpful. You can try these problems and to solve them, and then go and check your answers in the answer key. Have a quality day.